In this video, I will talk about case 6 of portfolio theory. Just to remind you what it is, this is where the losses x1 to xn are dependent variables and n is the number of investments, is also a random variable independent of the losses. All right. So I'm going to consider first the variable S, which is the total portfolio loss. This is the definition of the CDF. Now in the next line, I'm going to use the total probability rule, which I talked about previously. So it's a sum of the conditional probability of S, given n is a fixed number, multiplied by the probability of n. And I think I talked about this in previous videos. This is the total probability rule. Right? And in the next step, because this conditional probability, we are conditioning on the number of investments being a fixed number. Hence, what you have here must be the same as what we got in case 5. Right? So I can replace this with the CDF of S that we got in case 5. So that's what I'm going to do now. So it's going to be all right. This is the expression that we got for case 5. All right. So this equality here follows because of what we got under case 5. All right. So this is the CDF of S. Now the PDF of S. The PDF is simply the derivative of the CDF. Right. Next I'm going to consider the variable U, which is the minimum portfolio loss. By definition, this is the probability that u is less than or equal to u. Now once again, I'm going to use the total probability rule, and I'm going to write this as the sum from 1 to infinity of the conditional probability of u given n is a fixed number multiplied by the probability that capital N equal to little n. Okay. Now, the conditional probability here is exactly the same as the CDF of u we got in case 5. So I'm going to replace this by the result for the CDF of u that we got in case 5. Okay. Now this you can write as follows. You can write as a difference of two summations. Okay. Now the first is the sum of all the probabilities, hence it must be equal to 1. Okay. Right. So this is the CDF of u, and the next thing is the PDF of u. So you just differentiate the CDF with respect to u. Right, which is the derivative of this with respect to u. So you should differentiate this with respect to u, you will get minus sum from 1 to infinity of Okay, so this is the PDF of the minimum portfolio loss. All right, and the final variable I'm going to consider is the maximum portfolio loss. So the CDF of V is and once again I'm going to use the total probability rule. So this you can write as the sum from 1 to infinity of the conditional probability of V given n is fixed times the probability of n. Okay, so this is the total probability rule. Right, and in the next line, I'm going to replace the conditional probability by the CDF that we got for V under case 5, which was this. So this step follows by the result that we got in case 5. Right. All right. Now, finally, the PDF of V is the derivative of the CDF. So you should differentiate this. You can write it like this. It's the sum from 1 to infinity of the derivative of the joint CDF right, multiplied by the probability that n equal to n. So this completes case 6 and also completes the portfolio theory. And the next topic for this course will be something called financial risk measures.